All right. Okay, so we've kind of looked at, and by the way, the next lecture I think is also on dictionaries. So some of these questions we'll go over in a little more detail when we get to that part of our life. When we get to Thursday, but let's start over again, and let's try to resolve our IMDB problem that I posed you using dictionaries. Okay, so let's start off here. And you should notice this is an awful lot like everything we've done for the last couple of days, right? It all starts out the same. We come down here, we get a file name. Did we start a timer on this one? Yeah, we'll start a timer in a little bit. We come down here, we read each line of the file, we split it out, we get the name. Okay, but now instead of counts being a list, counts as a dictionary. And what we want to set up is we want to set up a dictionary that has as its index the name of the person we're trying to keep track of. And that has as the single value the number of times they appear in the file. Right, so let's see. Well, oops, I'm back at giraffes. Right, if name and counts, if we go back and look at, right, we looked at some code down here. We could do a membership test to see whether a key is actually in our dictionary, right? So we can say if the name is in the count, and I'm going to tell you that this, right, the keys are essentially kept in a set. So this is the same as testing for membership in a set. We could also write this as counts.keys if we wanted. That's essentially the equivalent. If that's the case, then what do we want to do? Well, if that's the case, then we've already put the person's name into our set or into our dictionary. So if we've already put them in, then what we want to do is we just want to say we saw them again. So count subname, right? We've seen person name one more time, so we'll just increase their count. If that's not the case, then we want to put them in for the first time, in which case counts subname, instead of adding to it, we're just going to set it equal to 1. Right? And that should be counts instead of count. Okay, so let's think this through. We're going to read each line of the file. We're going to find the person's name. If we've already found the name before, then we have a record for them on line 14, and we're just going to say we saw them one more time. If they're not in there, then we have to add them, and this is the first time we saw them, so we set the value to be 1. That's pretty much it. Let's pull some code out of here. And we know that we can get all of our keys out by using counts.keys, right? That's going to give us essentially a list. It's actually going to be a key item, but we can convert it to a list with the list call. Or, just as a shorthand for this, since we actually want to sort this anyway, we can do sorted. So that's going to pull out all the keys and it's going to sort them, and then we just want to print out the top 100 or the first 100 in alphabetical order, right? So what this is going to do, we don't. And we need to throw something in here to break us. Let's just say counter equals 0. And I'll just do a break. If counter we'll increment our counter, right? And if counter is equal to upper, we'll just do a break. There are other ways to do this. I'm going to be a little bit lazy. Okay, so what is this going to do? Well, we'll set our upper bound. It's either going to be the length of counts, or 100, whichever is smaller. We're going to walk through. We're going to print out either all of them or 100. Again, whichever is smaller. When we get to 100, we're going to break. We should fall out of there. We'll pop this in, do a little timing. And we'll do a little, let's see. And let's put a little time in here. Although, it's going to be pretty fast. Oh well. And we'll import time. Okay, so now we've just instrumented this a little bit so we can see what's going on. And if we run this, let's try it with hanks.txt. Where, let's see, line 25. Forgot an S. That looks better. Try running again. Okay, and yeah, we should probably print the person as well. The person is right. The person is actually stored in the key, so we'll print out the person and the value we've associated with the person, and run it again. And okay, so again, Bethan, Brad, Brigitte, Christopher, all ones. Mark, Mike, Paul, Scott, Steve, all ones. Colin had a nice run of 10. Jim had 6. Zach had 2, and the big man, Tom, has 41. All right, so this looks like it works here. What time did it take? 1/1000th of a second. Run it with a little bit bigger. IMDB 2010 to 12. Run that again, this time with the right file name, .txt. That'll work. That was fast. That took us 0.14 seconds, still awfully fast. And if we give it the big one, the big file name, IMDB data.txt. Boom, fast. Okay, we haven't actually asked the question who's busiest, or we haven't answered the question who's busiest, but we've gotten ourselves a good ways along the way, and that took 1.2 seconds to parse the entire file. All right, so this is a pretty fast solution. And this tells us how many times each individual essentially was in our IMDB file. All right, so solution we gave in class, first 100 individuals in alphabetical order. If you look at the second exercise, it asks you to go through and find the person, the busiest person overall, as well as finding out how many people only appeared once. So that's what the second solution is. Feel free to start from this solution. If you look at the code written in class for Module 16, you'll actually find out that here is the code you need, right? So you can start right from there. It's already there for you with a much nicer print. But what you need to do is you need to replace this part and figure out who is actually the person who appeared the most times. Okay? The upper bound, that whole maximum thing here, this is just because if we print out like 10,000, right, this would give us 120,000 names. It would be dominated by the print time, and the print would take us, would just throw out a lot of stuff that we don't really care about. This is just a demonstration that we found, the top, that everything looks sane. This is not by any means required. All right, let's go back to where we were, Lecture 16. Oh, somebody wants to see the encoding string on line 12. You can just grab it from the you could just grab it from the file in the data, in the code developed in class list. But it's just ISO encoding equals the string capital I, capital S, capital O, -8859-1. You can also use UTF-8. That will work. There are a bunch of them that work. This is as good as any, I guess. All right. And again, you can just grab that right from here. Right, if you just go to this part of our website. All right, we're back in our dictionaries. Where are we? We should be all the way down to here. Okay, so we've been looking at using names, or essentially strings, as the keys in our dictionary. Turns out that anything that we can put into a set, string, int, float, booleans, tuples that don't have unhashable things like lists in them, all of those can be put into our keys. Lists, sets, other dictionaries, they are not hashable because they're mutable. They cannot be keys. Oftentimes, just because of the nature of things, strings are the most common key type. Next lecture, we'll get into using integers. And float and boolean are really poor choices. And in general, I would open this up for discussion. But I'm not sure that it's going to be all that useful. Let me just go into why. If you're using a Boolean as your key choice, that limits you to two values, true and false. So in general, while you can have a Boolean as a key choice, and I think we actually gave it on a test one year, Booleans do very limited, you can have very limited entries in your dictionary, right? Dictionary sub true and dictionary sub false are the only possibilities. Floats are similarly poor choices because it's very hard to get any complex set of calculations to be the same down to the smallest, the least significant bit. So if you're going to use floats, you have to either do some rounding or some binning to make values that are close map into the same bin. So, you can use them. You can use both of them, but those are why they're actually pretty bad choices. On the other hand, values, we've been using integers, maybe floats when we were talking about animal heights, but you can use anything, right? Anything can be a value type. You can have a Boolean, an integer, float, string, anything we've seen so far, list, tuple, set, even other dictionaries can be the value part of a dictionary. So, we could do something, let's say instead of, one drawback of the solution we just gave you in class, was that Tom Hanks is actually in Polar Express about 6 times or something. So maybe instead of counting that 6 times, maybe we would want to maintain a set of movie names. And the times he appears, the number of unique movies would be then the size of the set. And we could do that pretty simply by, again, creating our dictionary. I'm going to come over here and create our dictionary. Oops. We'll do people, and I'm going to say Tom equals Hanks, comma Tom, because I don't feel like typing that in all the time. Right, so now we can do people sub Tom, and we can assign it an empty set. Right, and then we can look at people. Right, Tom points to an empty set, and now we can do people sub Tom dot add different movies. We can add Big. We can add Splash. What else can we add? Forrest Gump. We can add Philadelphia Story. Yeah, why not? I think I can spell that. I'm actually pretty good at spelling. My fingers aren't. Right, and we can look at people then, and we can see that Tom has been in 4 different movies, right? The length of people sub Tom. Right? People sub Tom. People is the dictionary. Tom is the key. The value associated with that dictionary key pair is a set. And that set has 4 entries. Right? And now we can add in again. Let's do some other ones. Let's add in Polar Express. And Polar Express, and Polar Express, Polar Express, and Polar Express, and Polar Express. And after all of that, because we added in the same value 6 times, we're only going to count it as 1. And we can actually look at people sub Tom, right? Or length of people sub Tom. I guess I already looked at that. All right. So, this is an example of making the value for a dictionary entry be a set. We are just about at the end of our time. We could also do tuples, right? We can come in here. I'm just going to grab this one and post it in. In this case, we have a dictionary countries, and we will make tuples the values. So the keys are the names of the countries. The tuples are population and continent. And if we want to get at the specific values in one of the entries, right, we can say something like this, right, where we set up name to be equal to one of our countries, Canada. Okay, and now, right, country subname. Right, country subname is the tuple associated with Canada, and we can look at the 0th entry, which is the population, or the first entry, that is the continent. Right, so this looks just like a double subscript on a list. It's, essentially a subscript, a key value on the dictionary. And since that returns a tuple, a subscript on the name of the on the tuple. Okay. For sets, Discard removes a specific element, and doesn't return an error. Remove removes it. I'll hit these, I think, quickly at the start of the next class. But discard removes an element without checking. Remove removes the element but throws an error, an exception, if it's not there. For a dictionary, it's the del function. So del countries subname, right? That would delete Canada. And now you'll see that Canada has been completely eliminated from our list, but not our hearts. And you can use things like, if you try to access a value that's not there in general. So if we do country subname, name being Canada, now that Canada is no longer there, that'll throw an error. But if we do countries.get name, okay, that returns just a blank. It doesn't throw an error if we use it there, and if it's there, it returns something. We'll go over the rest of these later. You can work through these yourselves. They're not all that hard, and you can get help on them with the help function. So I think that's all we have for today. Let me look at